Here's the blueprint for your transformation.
No, I forgot.
When you are adding, subtracting underneath the radical, that's left and right. When you're adding, subtracting outside the radical, that's up and down. Multiplying, of course, is vertical stretch or compression, and negatives always mean reflect. What to do with each of these is just first describe the transformation, and then graph it on the calculator and set up a table and graph the points. So if we look at this first one, square root of x plus 3, what does the plus 3 mean? Left 3, right. Left 3, okay? So let's graph it to find some points. So open up your calculator, y equals, let's put in square root of x plus 3. And you need to make sure that x plus 3, all of that is in parentheses. Okay, the parentheses are going to be really important today to just tell your calculator what is being square rooted or cube rooted. So x plus 3, close your parenthesis, and then graph, and you can see how my square root function moved left 3. You can see that on the graph. Then you go second graph, that gets you your table. And you're going to go back to errors, because no, you cannot square root negative numbers, so that's why it's error. And then I'm going to pick out some nice points, like negative 3, 0, negative 2, 1. What are some more nice points? 1, 2, 6, 3. And I would graph those. So negative 3, 0, negative 2, 1, 1, 2, 6, 3. And there's my graph. Okay. So when I'm grading this on homework and tests, the table of points and the transformations is going to be the majority of that problem. Okay, I will worry about the graph the least, as long as you have your table of points correct and your transformations correct. Okay. All right, let's do another one. So again, I have square root of x, and notice minus 1, the subtracting 1 is outside the radical. So what does that subtracting 1 mean?
Up and down.
Down 1. Subtracting 1 means down 1. And this is going to be different when you put in your calculator. You're going to have the square root of x, close your parenthesis, and then subtract 1. Because you do not want the subtracting 1 underneath the radical, you want it outside. So that's where parentheses, again, are really important. So graph, and I can see, yep, it moved down 1. Second graph, let's find some points to graph here. So I set up my table, x, y, and I could graph 0, negative 1, 1, 0. Let's scroll down, find some more points. 4, 1, 9, 2. So on these, if you have 3 points, 4 points, that's pretty good. 4, 1, 9, 2. And there's my graph. Example number 5, I have 3 transformations. What are they? 3 transformations.
Right.
Right, 2.
Dang.
And this is actually 2. Remember, negatives always mean reflection. You can't do a compression or a stretch by a negative. Negatives always mean reflections, so reflect over the x. And this 2, since it's bigger than 1, would be a vertical stretch of 2. So 3 transformations. Let's set up a table and find some points. So y equals, let's put in negative 2 square root x minus 2. Then you close your parenthesis after the subtracting 2. Graph. And you should see it got reflected and it kind of got stretched, pulled out. Okay, so that's one way to check yourself, is to make sure it matches. It also went right too, I can see that. Second graph, so let's see, I can do 2, 0, 3, negative 2, 6, negative 4. Anything else in there? 11, but that gets too big. So in this one, we only have 2, and that'll help happen when you get stretches or compressions. You won't have as many points to graph. And there's your graph. Number 6 here, the reason I want to do this one is because you have to make sure you put parentheses in your calculator. 1/4 is less than 1. That is a vertical compression of 1/4. Subtracting 1 underneath the radical would be right 1. And plus 5 outside the radical is up 5, okay? So what happens when you graph it, it's going to look a little weird. Parentheses, 1 divided by 4, then square root, x minus 1, close your parentheses, and then add 5. Because it was a vertical compression, whoops. Oh, I have 2 pluses. Because it was a vertical compression, it kind of looks like a line because think of your square root, it kind of got squashed like this, a vertical compression, okay? And there's not going to be a lot of points you can graph. When you have a lot of decimals, you're going to kind of look at what are the best decimals I can graph, is what's going to happen. So 1/5 is going to be really the only nice one to graph there. So then I would look at the easy ones to graph, like halves. Halves are pretty easy to graph. So 5.5 would be a good point. And then maybe another one, let's see, how about probably 10 and 5.75. Okay. And it's going to be almost, yeah, a straight line. And don't forget the arrow at the end. Radical functions or square root functions keep going forever. Let's look at a cube root one, number 12. Remember your cube root buttons under math? So I'd go 2 first, then math. Cube root is right here, the number 4. And then you're going to have x, subtract 3, then close your parentheses, because that subtracting 3 is underneath the cube root. And graph, and your domain on a cube root is twice as big as the square root. It goes left and right forever. So you're going to have more points to graph on this one. We've got to identify our transformations here. 2 means what? Vertical stretch of 2, and subtracting 3 underneath the radical means right 3. I can go second graph, and let's see. Usually I start with -10 on my x because my graph for my x's is -10 to 10. So -10, I don't really have a nice one until -5. So -5, -4. Keep going. There's some nice ones. 2, -2. 3, 0. 4, 2. Is there anything else? 11, 4, that's kind of too big. But that should give me a good idea of what it looks like. -5, -4, 2, -2, 3, 0, 4, 2. So it kind of looks like that. And you can use the picture of the graph to help you graph it. It's going to look the same.